If you're trying to build an offline-first collaborative desktop app that can work on all different operating systems, but you're a bit stuck on where to start, you're not really sure what to use, let me help you out and walk you through some options to try and move your project forward. If you've spent even a little bit of time in the world of web development, whether it be with something like React, something like Vue, Svelte, any framework that you love or hate or have to use, you've likely run into something called Electron, which is a very popular cross-platform desktop framework or tool, whatever you want to call it. And you also know, if you've heard of Electron, that it's pretty infamous for a few things. Quick aside, if you're familiar with Electron, you know how it works, you know the upsides, downsides, and you're pretty certain that it's right for your project, feel free to skip this part of the video and go to the end where we compare putting PowerSync in the main process in Electron or in the renderer process. And if you have no idea what I just said and you want to figure it out, stick around and I'm going to help you out. Now, as I was saying, Electron can be pretty infamous for a handful of different things. And the first thing that you're probably going to notice, or more importantly, your users are probably going to notice, is that pretty large bundle size. Even if you have a few lines of JavaScript and you make the most basic to-do app, calendar app, whatever your hello world thing is, you're going to bundle that application for all your operating systems, and the binary is going to end up being somewhere in the neighborhood of 100 to 150 megabytes, depending on what you're doing. Now, you might be thinking, like, why is that the case? That's because every download of Electron has an instance of Chromium in it, the engine that runs the Chrome browser. And this is also part of what makes Electron so powerful. Anything that you can do in Chrome, more or less, with a few exceptions, you can do in Electron. And to make sure that it is consistent with everything, they package that whole Chromium bundle into the app. So even if you have multiple Electron apps running on your computer, things like Discord, Slack, Spotify, I believe, uses it, maybe Figma. I'm actually not sure if Figma uses Electron. But all of those things, they're not going to share one Chrome instance. They're all going to have their own, meaning if you have a lot of these apps, they can start to add up. Now, while there isn't really much you can do to get around this, I mean, Chromium's going to be as big as Chromium is, there are newer frameworks, notably Tauri, that try to get around this problem by rather than including an entire instance of Chrome, they use the operating system's native web renderer so they don't have to download anything else, leading to much smaller bundle sizes. If you're interested in us making a video about that, let us know by shooting us a comment. Electron is also pretty notorious for having apps that can be pretty slow compared to true native counterparts. This is because, as you might expect, you're running a website inside of a desktop app rather than something that runs closer to the metal, like a native desktop app written in Swift or Kotlin for macOS and Windows, respectively. But luckily, there are a few things you can do about this to make it better. Firstly, and this may seem obvious, but whether you're in the web or in Electron, slow code is just slow code. If you have a website that is a little bit sluggish, it's going to be just as sluggish on Electron. Putting it in a desktop app isn't really going to make it faster if it's running in the renderer. Another thing that's a common gotcha is trying to run too much code at the app's startup. When you start up a desktop app, you likely want to run a lot of things, run a lot of maybe authentication scripts, login stuff, loading modules or whatever it is. And a lot of that can make the app appear really slow to start up. The official Electron website has a great post on a lot of different performance things. And one of the things that they mention and give an example for is how VS Code, when you launch it, notice when you launch VS Code, it's all white text at the start or non-formatted text. That's because it is trying to show the user something before it starts all of the extensions, all of the language servers, all of those things, and that makes the app appear faster because you can start doing something immediately. So currently, I've only really been talking about the bad with Electron because, I mean, as developers, we love to complain about things, but a really good saying is if either people are complaining about it or people aren't using it. And whether you like it or not, people use Electron for a lot of things. It has been around for a long time for a very good reason. A lot of companies, startups, individuals doing side projects have loved the way that you can write in one place and be able to easily bundle on a lot of different operating systems. And if you are making a CRUD app, something that isn't too complicated, something that doesn't need like too much heavy computation, something that's like close to the metal, Electron can likely do everything that you need and do it pretty well. Plus, something that I'm personally excited about, which isn't exclusive to Electron or even Tauri, is the improvements and updates that are happening to WebAssembly, which is going to help a lot of computationally intense code run much faster in a browser environment. If you're interested in WebAssembly, there are a ton of amazing videos about it and what the possibilities of it are, so it's definitely something that you should check out if you're interested. All to say, there is never a better time to be a web developer who is trying to make a desktop app, and you will feel so much better when you are delivering a high quality product to your users and just honestly for yourself, knowing that you're making something snappy and that's not sluggish. And a great way to make an app feel snappy is by relying on the internet less, which is where PowerSync comes in. PowerSync is a sync engine that uses SQLite on the client to provide a true local first experience. And by that, I mean, instead of, like, if your user does something, instead of pinging to the server, waiting for a response, your app is interfacing with a local SQLite database, and then the PowerSync client or engine, whatever you want to call it, is the one that is actually interfacing with your backend database and syncing it in the background. So to your users, they're just interfacing with something local, but all of that data is still staying in sync. If you've never used PowerSync before and are unfamiliar with what a sync engine might do to benefit your project, let me give you a quick crash course on what it is. So in super typical web development, when writing an app, we usually think about two major parts when we're writing an app. We have our front end, which is everything like our UI, and this is running on the client's computer. So UI running on client's machine. Or let's do user's machine, make them sound like humans. User's machine. So you have a front end, and then you typically have some sort of back end that is running a service on a server. Running service on a remote server. And this is where all of your data is usually stored. So these are things like user data, really anything else. And usually, in order to make your app work well, you need to have a back and forth between these two. Now, this is usually fine if you're just filling out forms. You don't really need that much interactivity. But when you're trying to make a collaborative app or something that needs like quick access to things, you're going to find that every time, let's have our little data block here. If this is some sort of like data, wow, that looks great, thanks. If this is some sort of data and it's going back and forth, every time it goes, okay, back end to the front end, update, go back, front end, back end, front end, back end, front end. Every time that happens, there's just a little bit of latency. And so there's two things we're trying to deal with. One, let's make this white. One is latency on every interaction. And plus, if the user, like constant need for internet access. And of course, what that means is like if your user is using an app and you're expecting them to constantly have access to a server, maybe they're in an area where the internet is choppy, maybe they are planning to go to an area where they need to go offline, you're going to be kind of out of luck there. There's no real easy way to like cache all of that unless you have like your own manual solution, which if you've tried to do that, you know how difficult it is. So, of course, you probably know where I'm going. This is where PowerSync can come in to make things really helpful. Not only does PowerSync provide this like local first experience, but in a lot of ways, it just makes the whole process of writing apps that rely on these network connections just a lot easier. Rather than trying to constantly make sure everything is in sync yourself, pulling everything, trying to do conflict resolution, PowerSync not only does that for you, but it lets you build your app without the assumption that you constantly need internet access for everything. We have a lot of resources on the PowerSync website going into the exact details of how this works and what it can be really good for, but I'll give you a crash course on sort of how you can expect it to work in your app, especially as a drop-in replacement if you're using Postgres already. So rather than this whole front-end, back-end directly communicating business, let's clear this up. Rather, instead, we have our front end. Let's put this over here. We have PowerSync, make this a bit smaller. And critically, these two are talking to each other, front end and PowerSync. They are constantly talking to each other, and then PowerSync is talking to the back end. Critically, the reason that this is so powerful is that now the only thing your user is interfacing with is this, which is happening on the front end, or on the client's machine, all on client's machine. And then you don't actually have to worry about whether or not you're connected with your backend or not, or if you have internet connection. PowerSync is going to act as your quasi backend using a local SQLite database, and it's constantly going to be syncing with the backend. If the internet connection cuts out for a bit or even a while, that is the whole point of PowerSync, is that everything is synced, so it's local first. And again, we go into a lot of detail on our website about how this conflict resolution works, and honestly, when you look at it, it kind of feels like magic at first. If you're a bit on the fence on whether or not this is right for you, the good news is that it's super easy to try. We have a lot of demos on our GitHub. But if you're thinking about putting this in an Electron app, which is probably why you clicked on this video, there are a couple things we need to talk about with how you might want to put it in your Electron app, and talk about it in a good way, because you actually have two choices for how you want to do this. The first choice you have is our JavaScript web SDK. This is the exact same SDK that you would use if you were putting PowerSync on a plain old website, not one in running in Electron or any other desktop framework like that. This one you can use exactly in the website, and it works just the same in Electron. The benefits of this one are that it is, one, the easiest to set up. You don't have to deal with any sort of cross inter-process communication in Electron. I'll get to that in a moment. And second, if you're using something like React hooks, React, Tanstack Query, or Vue, we actually include hooks that hook into our library directly, allowing for a much easier setup and development experience. The other option, of course, you may have guessed it already, but is our Node.js SDK. Rather than running in the renderer or what you would be a website, this is running directly in a Node.js process, meaning it's going to be a good bit faster and much better for large query volume applications. Now, if you're sitting here thinking, okay, great, like I have Electron, why would I not choose the Node.js client? Isn't it significantly faster? Wouldn't that be better? Don't I want the most performance? Well, yes, it is faster, but there are a good bit of caveats that I want to walk you through. And the choice isn't actually very black and white, depending on not just the type of app you're making, but the type of team you have, whether it's a team of just you, or a larger team, or how familiar you are with Electron and its IPC communication. IPC, of course, stands for Inter-Process Communication, or as I like to call it, Intense Plumbing Code. Because when you write IPC, it's a lot of boilerplate, it's a lot of functions, you need to go to like a preload script. But if you're thinking to yourself, like, what is this IPC? You're not very familiar with what Electron is. Let me go through this again. If you're familiar with Electron, you can skip ahead a few seconds from this part. So Electron has what is called a multi-process model, and the official Electron website goes into very deep detail about that. I will spare the intense details for that if you are curious, but all you really need to know for this case is Electron has two processes, and I am sorry, my mouse is freaking out. Electron has two processes. They have the main process and the renderer process. There's also like utility processes and a few other things that you can do, but for this case, let's just think about this. Renderer process. So the main process, you can sort of think of like your server. It's very like sort of like don't go too deep into that. The reason I say this is because our main process is running. Let's make our renderer blue, baby blue. The main process, this is running in a Node, in a Node.js environment. And that means the similar type of thing if you're running like Express or something like that. If you're familiar with Node.js, it is basically a system process that is running JavaScript. That means that it has access to things like the file system. Of course, you can't access the file system on a website. It has access to things like tray notifications and other OS stuff. Since this is a Node.js process and it is running closer to the metal and not in like a sandbox browser environment, this is usually quite, not significantly, I'd say maybe like quite a bit faster than web. Now, the renderer process is what it sounds like. It is the process that has the renderer in it. This is your Chrome tab. This is the same sort of code that you would have when you run a website. When you're building a React app or anything like that, that code is running in the renderer process. And in Electron, you can have multiple renderer processes, like if you had multiple tabs. But for now, let's just pretend we have one. This is running in a browser environment. And the other things you will have in here will be this will be where your UI is, and where the user is interacting. This is sandboxed, meaning that this cannot directly access the file system. Directly access OS functions. And this is exactly where our IPC, or intense plumbing code, comes in. Because of this, and I know I'm giving IPC a hard time, because of this last thing I said, cannot directly access OS functions. If you are making a desktop app, you likely do want to do things with the file system. You want to have tray notifications. You want to do native desktop things. You want to change the thing, the file, view bar, all of those things. All those things Electron can do, but you have to do them in the main process. So if you want your main process to interact with your renderer process, you need to create an IPC bridge. This is inter-process communication, as I said, and the only way that you can talk to each other is usually through serialized data. Let me write that down, serialized. By that, I mean things like strings, things like numbers, strings, basically that, like anything you can send over JSON, you can send over this bridge. Sometimes you can write callback functions, but that's not usually what you would do. So now that you know about these, great, we have the main process, renderer process, and I've told you about the two SDKs. Now, where should you put PowerSync in this? If you're going to make a local sync engine that your app is constantly talking with, which one is the better choice for my app? Let's start with the renderer process example, because I'm going to guess a lot of you are probably going to want to start with this one, as this one is a lot easier to just get something up and running with. And if you are trying to transition an Electron, or like a website, into an Electron app, this is going to cause the least overhead or setup. Move this around a bit for you. So when you put PowerSync in the renderer, let's say PowerSync is here, the benefits that you get are, one, you have access to our UI hooks. These are things like here, let me make this bigger for you. You have access to like our UI hooks, things like React, Vue, TanStack, Query. You also need no IPC communication, no IPC, because everything is happening in the renderer. This also means, of course, that by no IPC, I don't mean your app isn't going to have no IPC. There's still some you need to do. But as far as PowerSync is concerned, you won't have to do anything. So, of course, this means easier setup. This will be less, when you do something like this, it will be less Electron-like. Like you're not going to be really doing much in the main process. You are going to mostly be building this as if you were building a normal website, which, another very important point, if you plan to make this a Electron app and website, like you have deployed in both places, then this option is significantly easier to transfer. To online app. Okay, before we go into the downsides, because I think the downsides of the renderer are probably pretty obviously the pros of the main process, let's go ahead and copy this. And let's get into the main process. Now, of course, the biggest and most obvious and noticeable pro to this will just straight up be faster. Node.js will be faster than the browser. And this isn't just like a Node.js thing. This is because of our underlying SQLite driver. So PowerSync relies on SQLite, which relies on a file system. When you use PowerSync in the renderer, you are using a virtual file system. So like there's a lot of different ways that the WebAssembly drivers that we use do that, but effectively what that means is that the browser is trying to simulate a synchronous file system, where when we are in Node.js, we are using the better SQLite 3 SQLite, better SQLite 3 driver, which is native performance. Gets you native performance. And honestly, this is like, believe it or not, this is like really the main pro of Node.js. It is going to require more IPC. Let's go to cons. It's going to require more inter-process communication. So cons. This requires more IPC. It also requires you to make your own UI hooks, which doesn't have to be too hard. You could use something like Tanstack Query to do that yourself, but you're not going to get the like ones that the reactor view ones that we included. This is going to effectively be, something, it's going to be a lot more manual, a lot more hands-on. And to you, that might be exciting, but if you're like just getting started, just want to get something to work, the renderer might be your better option. Super quick, I've documented the cons of the renderer over here just so you know what you're getting into, which is that it uses the browser's virtual file system and it is slower than the Node.js version. If this is something that you're curious about, you want more technical details about what that actually means, we have a blog post explaining how our new PowerSync core in Rust works, and it goes into a bit more detail on how that works. It's really interesting if you're into it, but if you don't care, we're going to get into the numbers of exactly how much faster the main process is, because you might be thinking, well, I want the faster thing, but how much faster is it? We're going to show you. So here are the numbers. As you can see, if you just take a quick glance with our node column on the left, this is in the main, us doing it in the main process, and our web column on the right, and you'll see the multiplier on the last one. Node.js pretty much sweeps in every bulk operation that we did. Of course, you might not be doing 5,000 to 25,000 operations at once, but this multiplier would still apply for that case. So if you were just doing 10, even though it might be like half a second in that case, it would apply whatever that multiplier is. Hypothetically, of course, this is an imperfect benchmark, but what I think you should get from this is if you are certain that your app is very, very query heavy and needs every single essence of performance that it needs, Node.js will be a lot faster. But you're going to pay for that with setting up the IPC with Electron. Additionally, if you want to move your app eventually to a website, you're going to have a much harder time trying to transition the two with the way our SDKs are right now. More on that in a second. With the web, even though you have a slowdown, in some cases 5x, but in most cases around 1.5, the development experience is going to be a lot easier, a lot quicker, and because everything is going to be in the renderer. You're not going to need to communicate in between two things. You're not going to need to write your own hooks, and it will overall just be a lot easier to get a minimum product off of the ground. So let's wrap up by summarizing when you should pick both, at least for getting started. So you should pick the renderer when, one, you know or want to get started quickly, are certain you want to also make a website, and lastly, if you want to use PowerSyncs, included hooks. Let's fix this up a little bit. Next, you would want to pick the main process when you need every drop of performance, when you are comfortable setting up your own hooks, and if you are comfortable setting up IPC. Now, notably, so these are the two things. Notably, with this video, we do have an open ticket on the PowerSync, and there's also a blog that is accompanying this video. We do have a ticket open on the PowerSync website for an Electron SDK. We are still in sort of the works with like what? Oh, I think it's about to crash. Never mind. We are sort of still in the works with what this might be. A few ideas we've had is like if we were able to, when you had an Electron app, be able to solve that problem of, okay, we know we want to have a website eventually, but when the user decides to download the desktop app, like let's guess, for example, using the Discord online platform versus the Discord desktop app, what can we do to make the desktop app snappier once we have access to raw system resources? And in a hypothetical Electron SDK, we might be able to do that. If this is something that you think would be really helpful to you and your project, please leave a like, leave a comment, let us know, because this kind of thing obviously is very demand-based. So if you think this is something you could benefit from, please let us know. If you made it all the way here to the end of the video, awesome. Thank you so much for sticking around. If there was something that you wish that I went into a bit more detail in, or you have a use case that you think I didn't cover or didn't answer a question that well, please join our Discord, reach out to us. You can also leave a comment and we'll be looking at those, and let us know what else you would like to cover for PowerSync and how we can help you build better apps.